So this is our second approach to pointers. Let's see what we can improve based on the first approach. So in the first approach, we can see that we can ignore some of the pairs, right? The pairs that had 11 and 15, right? So we can ignore those pairs. Our target value is still going to be 9, and we can ignore 15, anything that contained 15, because like these two numbers is already greater than 9, so there's no meaning of checking these pairs. So let's say somehow we can sort the array in ascending or descending order. It doesn't matter. So after the sorting part, we have nums becomes 2, 7, 11, 15. Okay. So now our searching range for the target is this whole array. But let's say we define a pointer that points to, let's say 11 for now. And since 11 is already greater than 9, we can just ignore all the elements right after or follows 11, right? So we can just ignore 11 and 15 or any element that is greater than 11. We can just eliminate this part. And now our searching range is just going to focus on this part, 2, 7. Or let's say our example was a little bit different. Let's say our searching range is now 1, 2, 7. So this is our first searching range, and we move the pointer to the left because we need a smaller number, right? And because we need two indices, like we need to find two elements that sums up to the target value. So let's define another pointer at beginning. So basically what the second approach is doing is we define two pointers at the very beginning at one pointer points to the beginning and the other pointer points to the end of the array. And basically we just keep stringing the arrays or the searching range, and the two pointer never crosses each other because we cannot have the same indices, right? So if the element at the first pointer plus the element at the second pointer is greater than target value, then we must move the second pointer to the left, right? Because we're seeking for a lower number that adds up to 9. So basically our pseudocode is something like while first pointer is I and then second pointer is J, and they never crosses each other. So if temp or nums plus nums J is less than targets, we move the first pointer, this is I and this is J, to the right. And else if the sum of these two pointers is greater than targets, we're looking for a lower number. So we need to move the second pointer to the left. Well, else we have found a solution, right, in the searching range. So let's see, so 1 plus 7 is less than 9, so we move the first pointer to the right. So we have our searching range becomes 2, 7, and 2 plus 7 is 9. So this is the solution we're looking for. We just return the index, right? Return the index I and J. Okay, so this is the basic idea. So in the real implementation, we have to define a hash table, right? That that stores both index and the value. Because once the array is sorted, the ordering is messed up, right? So we need to keep track the index and its value. So we need to have a I don't think we need a hash table, so I think we just need a tuple that is like, let's call it temp, an array of tuples. So we have value and then index. And basically we're just gonna sort temp based on value. So that is the element in the array nums. So after that, we're just gonna do the searching range. We're just gonna keep shrinking the searching range until we find a pair. Otherwise, we're just gonna return -1 and -1. So that's that. This is the data structure we need for approach 2, and this is the core algorithm. And okay, so now let's talk about the time complexity. Well, sorting an array is gonna, in Python or in other language, I think the optimal sorting is log n for an array with n elements. So for sorting, we have O of n log n. And for shrinking the searching range, we're just iterating we're just moving the pointers from left to right and right to left, right? And they never crosses each other. So that means we never check. That means we never check the same element twice. So therefore, the searching part is going to be O of n. So in overall, it's going to be n log n, because this has a higher order. And for the space complexity, we have O of n, because we store the value and index in a temp array that has length equals to the nums array. So we're sacrificing more space for less time. So time complexity is n log n, and then space complexity is O of n. This is the coding part for strategy 2. Okay, so first I'm gonna store the values and index as a tuple for nums, the nums array. So stores index as a tuple. and then we're gonna sort the temp array based on the first value, the first element. So temp dot sort, and okay. So let's define our 2 pointers. And it's the length of nums. So while I is less than j, right? While while the 2 pointers doesn't cross each other, and check if temp I, first element of temp I plus temp j 0 equals to target. If the elements at the 2 pointers are that sums up to the target value, then we just simply return their indices. Well, if their sum is greater than target, we move the right pointer backwards, right? So j minus equals 1. In the last case, then if their sum is smaller than target value, then we move the first pointer to the right, right? So 1 forward. If there's no such value, then we just simply return -1 and -1. I think that works. Okay, so it passes the first test. Submit. Okay, so it's still kind of slow, but it passes all the tests. So here's the code for approach 2.